So, welcome to my presentation on JavaScript Natural Language APIs. First of all, I wanted to warn you, in case you couldn't tell from the title, that this is not a serious talk. When you're being serious, you think in a business-like way, and you reason in the correct direction, identify a need, and then find a way to satisfy that need. I'm going in the opposite direction here. We're going to start with some interesting technology, available for free, by the way, and see what we can make with it. Who cares if it's practical or even if it's anything users want? After all, nobody wanted a spring that could walk downstairs. Nobody was in need of sticky goo that could pick up the Sunday comics. Also, I'm not going to go deeply into code. I'm not even going to show you the inner workings of anything. The structure of the talk is this. I'm going to show you some software building blocks and a couple of apps you can build with them. Here are the building blocks. It's these APIs. I'm going to show demos of each that are minimal, by which I mean the code is just big enough to do something and no bigger. Each of them shows how one API works on its own. The idea was to keep them clean and free of styling or inessential features so that they'd be easy to pick up and drop into a larger project or chain together, as I've done here. Now that's my redeeming social value. I'm also presenting two toy apps cobbled together from these APIs. I call them toys for two reasons. One, because they really don't do anything all that useful, and two, because they are like skill-based toys in that you have to learn an otherwise useless skill to enjoy them. There are apps that change the world, and then there are other apps that have to wait for the world to change around them. These are the second kind. You might say they're ahead of their time. Last year, about this time, I got excited about speech as a way to interact with a computer. There's something magical about it. You don't have to touch anything, move anything, do any work at all on objects that are external to your body. Just saying something causes my computer to react. It's action at a distance. Now, speech has a lot of great qualities. It's easy and high bandwidth. We would usually rather be talking than typing. Some of us would rather be talking than doing almost anything else. If you talk for a living, you're lucky. It's one of the first things you learn, and it's the last thing to go. If you're interested in making interfaces that are easy to use, well, one aspect of ease of use is ergonomics. Reduce the physical effort needed to get something done. One click is a nice goal. Speech offers the possibility of 0 clicks, which by traditional standards makes it a truly effortless interface. No clicking, no typing. Just say the magic words. When you start thinking about using voice input, the first thought is of voice commands. This is hard to do well. It can be incredibly frustrating for users. Because of the errors in speech recognition, you end up limiting your vocabulary as you design the system, which means the user has to know or guess the available commands. If the computer gets a voice command wrong, it will do the wrong thing or nothing at all. But the real big problem is how can you make it easy to recover from errors? There will be errors, not only in speech recognition, which are likely to be unavoidable for some time, but in human speech production, which will never be avoidable since we are human and we make mistakes. Now let's look at the difference in effort between the two input methods, command line and voice, when we're dealing with an error. With the command line, you hit up arrow and bring back your failed command, go left a bit, and retype just the part that has the mistake. And then you resubmit it. It's pretty efficient. With voice, there's no go back. So you have to try and try again, and that can be super frustrating. Here's Fred Armisen being a glasshole on Saturday Night Live trying to get it to connect to the CBS Wi-Fi. The password is Peacock. 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 Frustrating as hell. The keyboard really is a great, and the keyboard and screen make a great interface for precise input. Voice input causes more trouble than it's worth when you need precision. Typing is digital in the original sense. You do it with your digits, and each keystroke either succeeds or it doesn't. It doesn't matter how hard you hit the keys as long as you hit them above a certain threshold. Speech, on the other hand, is analog and contains deep information. So the standard methods of using speech for voice commands or transcription, there is a third possible direction that might lead somewhere interesting someday, and that's overheard conversation. That is what I'm going to use as input. With the new always-on voice recognition chips, your cell phone and computer will be able to pick up on any speech going on around them. There's this thing called life logging, where you keep your device on all the time. And that brings us to my question. Can a computer make itself useful by listening to my conversations? Okay, enough for the preamble. Let's start the demos. First, here's the easiest way to use speech in a browser. Town and country. Perfect. Now, that's a nice thing. It's so simple, just this one addition to the input element, but it's hard to make use of it. It stops recording the moment you pause, more than about half a second, and it gives up if you speak too long. It only accepts short phrases. There's no feedback while you talk, so you don't know if you're speaking clearly enough. Since it only works on short bursts of speech, you have to keep your hands on your mouse and keyboard, which means it can't be used to make a hands-free interface. Then, last year, Chrome came out with support for the Web Speech API, or at least the speech recognition part of it, which is the most interesting. Let's take a look. Okay, this time you're able to see what it thinks you are saying while you talk. I mean, what it thinks you are saying while you talk. You get to see its many attempts to guess what you're saying. That's the gray text you see. And you can watch as the language model finds the most likely fit. You can pause and it keeps on listening. You can pause and it keeps on listening. So this really allows what you could call a passive voice interface. So let me show a little code here. So this is how the hypotheses are displayed. We get an on-result callback many times a second with results in two parts. One contains the words speech recognition has made a decision about, which we load into a buffer called the final transcript here. We get informed about new words that have made it to the final transcript only once, so we can accumulate them in a buffer that gets mirrored back to this black span. The other is the system's guess about what you just said. That gets refreshed in each on-result event and displayed in the gray span. The result is that words bounce around in the gray area until things settle down, and then they move into the black. Now, here's the central observation I'm making. If we can somehow get conversational input from users, then we can apply standard information extraction tools to it, even though those tools were developed to handle written text. Here are a few. I'm going to use two of these, named entity recognition and machine translation. You'll also see the effects of sentence segmentation here. So let's look at NER first. I'm using Alchemy. They make 1,000 queries free per day, which is perfect for a toy. Let me click on this canned thing. So this statement shows us that it found Barbara Mushabush and Bob as two people. Everett and Olympia are cities, and Washington is a state. I picked this ridiculous name so you could see that it's not using just a dictionary of names. To set this up, I used their PHP library on their server, on my server, and then Ajax. So now we have continuous speech recognition, and we have the text from continuous speech recognition and a list of names that were mentioned. What can we do with this input? Well, clearly the intelligence community has a serious interest. With metadata about phone calls, they can build a network of people you talk to. With NER on the content of phone calls, they can build a network of the people and things you talk about. There are research grants for that. So it has an evil use. I'm using evil in a special sense. Some of my best friends are evil. But can it also be used for good? What could your computer do for you if it could listen to what you say to other people? Okay, hold that thought for a second while I go off on something completely different. Jon Stewart. If you have your own fake news show, then you've got a staff of interns who manage this rectangle over your shoulder. They find pictures of the people you talk about and throw them up there when you mention them. Now, here's my pitch. Have you ever wished you had the same thing? Your friends don't get your references. You end up explaining things over and over, waving your hands in the air. Then, my friend, you feel the pain my app will relieve. It's the first in a new category, computer-aided conversation. The computer listens to your human conversation. When it hears a name, it searches for images of the things you mentioned. Okay, it may be ridiculous, but for the sake of argument, let's say we've decided to show images based on names you mentioned in conversation. We already have 2 of the 3 APIs. We need the missing one is some way to get relevant images. Well, Microsoft Bing does that nicely with 5,000 free a month. Let's see Scarlett Johansson, misspelled, no problem. Let's look at Flickr. Free again. All right. Now we're ready for the talk show demo. Okay, so the setup here, great, it's listening already. Now the setup here is that we're trying to decide between 2 movies. First, there's the Joaquin Phoenix movie, where he's a computer nerd and Scarlett Johansson is the disembodied computer voice that he falls in love with. Come on. Looks like we're having a little bit of technical difficulties here. We'll give it a second longer. Sometimes it catches up. Doesn't look good. It's looking very bad, actually. Come on. Finally. All right. You got Joaquin Phoenix. And Scarlett Johansson is the disembodied computer voice he falls in love with. It's by the guy who did Being John Malkovich. Then there's this movie by Martin Scorsese with Leonardo DiCaprio. It's got Jonah Hill and Margot Robbie, who really does look a lot like Jamie Presley. Oh, and there's Matthew McConaughey. I heard someone say he's this generation's Robert Mitchum. Plus it has the French actor Jean Dujardin. Oh, great. All right. Look, it got a lot of stuff here that I just said. That was a pretty easy way to pull up a bunch of images about a couple things I have a minor interest in at the moment. If you get past those network errors. Now, that could have been me talking to a friend who was kind of hard of hearing and very slow to react. I wasn't really using the computer. It was just there, listening, acting when it had something to offer to the conversation, like an attentive servant. Wittgenstein had something called the picture theory of meaning, where a statement is meaningful, that is, true or false, if it pictures a state of affairs in the world. The verb picture is being used metaphorically here, but I'm going to be unsophisticated and take it literally. Let's say a statement is a kind of picture. And if a statement pictures the world, then what do the proper nouns in it do? Well, they picture the things they refer to. Going from a statement to a picture of the world will be hard, except in the simplest cases, but it's easy to go from a name to a picture of the thing it names. If that makes any sense to you, then you will believe me when I say this app is the first step in a grand project to turn speech into pictures on the fly. Now, oddly enough, after I wrote this, I have found out that the guys who are into deep learning at Stanford and Google are actually talking about matching sentences and images. So in TalkShow, a name is meaningful if we can find a picture of that thing on the internet. Of course, with a little effort, we could add pictures of your family and friends, so they pop up when you talk about your vacation, or a graph of last year's sales figures for the office. The theory that says this could be of value is that communication involves, among other things, calling up pictures in your mind of the things we're talking about. Having a real picture on screen can avoid the miscommunication that happens when our two mental images are fundamentally different. We may have different objects in mind. But in any case, I take it as given that the benefit of seeing what you're talking about is small at the moment. So the effort has to be correspondingly small. At the moment, it means opening up your laptop and getting everyone to hover around it. I think we have a general problem in our time with screens. We have many ways of handling them, none of them optimal. There are screens of every size. Here we are now with our little screens in our little hands. You're with a bunch of friends, everybody's watching their own cell phone, and somebody finds a video they want to share, and they have to pass their phone around so everybody watches the video in turn. Someday, I think this is going to change, and this kind of picture will look so 2014. Here are the peace talks on Syria in Geneva. They scattered some screens around on the floor. This seems a little funny, but it's actually a reasonable solution to the problem of sharing when people are in a conversational configuration facing each other rather than a presentation one where everyone is facing the same direction. There are screens showing up in public spaces like this. There are screens, giant video walls showing up in people's houses. So one of the things I like to do is extrapolate wildly into the future from limited information in the present. And I predict that screens will get bigger and will take over more and more of our visual space during the day. In 50 years, will screens cover every vertical space? Will they be everywhere like wallpaper in the 1940s? All interiors will become holodecks? Well, if that happens, then this app will find its niche. It's an exercise in ambient computing, where computers take whatever input they can find in their environment and try their best to deliver something we'll want. Another warning to the reader, my predictions don't always come true. When I saw that they started putting advertising on the floors of supermarkets, I thought it wouldn't be long before they cover the floor wall to wall. Well, that didn't happen. The first time I got a robocall, I thought, what's to prevent them from flooding the phone lines with these until it becomes a general denial of service attack? We avoided that one too, so I may be wrong about screens covering every vertical surface. Okay, so that was something that you could do with image search on names found by named entity recognition operating on the output of speech recognition. The next app combines speech with video conferencing and throws in machine translation because why not? For the communication platform, I picked Web's real-time communication. It's peer-to-peer voice, video, and data communications through a browser without plugins. The browser in this case is Chrome. I think Firefox supports part of this. You don't have a phone number. You just navigate to the same URL as someone else, and you're in contact. The video part of it isn't really essential for my purposes, but this platform lets me control the web page display for each user during a call. A purely audio call, when you add translation, is very hard to manage because of the problem of not only speech recognition errors, but machine translation errors. Combining video conferencing with just speech recognition is already interesting if the speech recognition output is visible to each user. Just getting an accurate transcript of the words spoken during a serious conference call would be great, but only if it's accurate. Add translation and you get the power, but also you increase the power, but you also increase the risk of error. So now about machine translation, it's particularly challenged by speech. Statistical machine translation models are trained on text that was translated by humans for their own human purposes. And people working in MT were very lucky to find all this existing data to leverage. But that meant they worked with text that was especially good. Written text that was worth translation by a human usually passes a high bar of grammaticality. Sentences and paragraphs are well formed. Speech, on the other hand, is not. It follows rules of grammar that are different from text. It's rarely translated except at the UN, which is a special kind of speech, so real-world training data for voice-to-voice translation is scarce. You might think of movie subtitles, but they're really terrible. So for translation, I'm going to use Bing. You have to register, but they give you 2 million characters a month for free, which is hard to use up. So here's my Bing translator. Just type some stuff into here and hit translate, and there you go. So Bing works over JavaScript by issuing you a token that's good for 10 minutes. There's no cost for a token except the back and forth to this token issuing server. So you could be lazy and ask for a token on each request. But you can remove that overhead by getting a 10-minute token, and during those 10 minutes, you just go directly to the translation server using the token. If someone snags it from your web page, it's not very useful to them unless they keep snagging them every 10 minutes. So you can store your account ID safely on your server and use it to get the temporary token to pass down to the browser. This script requests a 10-minute token on load and runs a timer that fires every 9 minutes to ask for another one. If I can't get a new token in a minute, then I just failed disgracefully. So we just added WebRTC and translation. We also need text-to-speech. And those three will let us make this classic toy, the translating telephone. I'm updating the classic by using video, not just audio, multiple speakers in a conference, not just two, and multiple languages, not just two, as well as synchronized text display. So for text-to-speech, that's the last thing we need. It will soon be possible to use the Web Speech API. Until then, the text-to-speech in Google Translate's pretty nice. Several languages have real voice synthesis. The quality of synthesized speech has improved dramatically recently, and it's really the least of our worries.
Hello.
Je suis désolé, mais la maison est un vrai bordel.
When there are more than 100 characters, you have to split the source text into chunks and speak each chunk in sequence, and yes, it can sound funny. It's as if one sentence ends mid-sentence, and then another one starts up.
You can also have it speak an English sentence with a very strong French accent.
At what time is the meeting?
I kid the French with love. Okay. Now we're ready for the final demo. This idea actually serves a purpose, multilingual communication. Unfortunately, it also places too heavy a demand on its underlying technologies. It requires a precision not yet achieved in speech recognition and machine translation, in spite of the fact that both of those have made huge strides forward recently. For one thing, translation means we have to make sense of everything being said, not just the names. More importantly, the interface runs two error-prone processes in series. Both ASR and MT have high error rates. Doing one on the output of the other is just asking for trouble. So, here we go. My name is John and I speak English. Okay. So first I'm going to show you some things you can do with it alone without having another person online. The main purpose of the app is to translate everyone's speech during a conference call to your own language. In order to allow a single user demo, I added this illogical feature to translate yourself to yourself. There's no practical purpose to this feature, it's just for fun. If I click on my image, it maximizes and the text shows up as subtitles on my video. This is presentation mode. Which is appropriate when one person is presenting something without interruption. I meant to say which is appropriate. Yes. There's also the multi-user conversation mode that I just showed you, where you see a transcript of everyone's output. There's and that's appropriate when a lot of people are speaking and there's a lot of back and forth. Now, in either mode, speech is captured as source text in your native language and sent to all the other participants. Then it's translated on their browser into their language. To end with, here's how it works between an English speaker and a Korean speaker.
Okay, so hey Ali, was this application easy to use at first?
아니요. 처음에는 사용하기가 정말 어려웠어요. 제가 연습을 많이 해야 했어요.
So yeah, I know what you mean. It's a toy, kind of like a yo-yo, where you have to learn a certain skill. Until you learn how to use it, it's just a round thing on a string.
네. 그런데 지금은 제가 방법을 찾은 것 같아요. 충분한 연습을 한다면 누구든지 이것을 사용할 수 있을 것 같아요.
Okay, so that was 8 API demos and 2 apps. I hope you get a chance to try them out and make your own useless inventions. Thanks.